In this problem, a company estimates that it can sell 5,000 units each month of its product if it prices each unit at $65. However, its monthly number of sales will increase by 10 units for each 10-cent decrease in price. So if they decrease the price, they'll sell more items. The company has fixed costs of $300 and the cost to make each unit is $4.70. We want to find the level of production that maximizes the company's profit. How many units should they produce, at what price, and what will their profit be? To get started, we have to define a variable in such a way so that we can describe profit, because that's what we're trying to maximize. And I only want to use one variable to do this. The best way to do that is to let x, or whatever variable you want to use, but I want to call it x, let x represent the number of decreases in price. So the number of 10-cent decreases in price. And then we'll be able to describe everything we need in terms of x. But it's very important that you have a clear definition of what your variable should be here. So I like to write it fully out. Okay, now we are trying to maximize profit. Okay, profit is equal to, just generally speaking, profit is equal to your income or your revenue minus your cost. So if we want to write profit in terms of x, we need to find revenue and cost in terms of x, and then we'll subtract. So revenue, let's see, the revenue is, we know that when the price is $65, and that's basically when x is 0, so we've had no decreases in the price from the $65. So when x is 65, we sell 5,000 units, and then if x goes down, we sell more units. So revenue, just in words, here, revenue, actually let's do this down here, is the number of items that you sell times their selling price. In words, it's the number of products sold or items sold times the price that they are sold at, or their selling price. Okay, so how many items are we selling and what is their selling price? And we need to write both of those expressions in terms of our variable x. Okay, the number of items sold is initially 5,000. But with each 10-cent decrease in price, we sell an additional 10 units. So every time x goes up by 1, we sell 10 more items. So plus 10 times the number of 10-cent decreases in x, decreases in price, so 10 times x. We can add that to the initial amount of 5,000. That's the number of items being sold. Their selling price, well, we start at 65 and then we decrease the price by 10 cents with each x. So minus 0.10 times x is their selling price. Okay, so just to coordinate here, the number of items sold is equal to initially 5,000, but then we add another 10 items for each time x increases by 1, and their selling price is initially 65, but we subtract 10 cents for each time x increases by 1. So there's my revenue in terms of x. I've also got to get cost in terms of x. So cost, if we break it down in words, let's do a different color here. Cost is equal to your fixed cost plus your variable costs. Okay, fixed costs we are told are $300 here. So cost in terms of X is 300 plus the variable cost. Well, let's see, the cost to make each unit is $4.70. So it costs $4.70 to make each item, and we're assuming here that you're actually selling every single item that we make. So if we're selling 5,000 plus 10x items, let's assume that we're actually producing that exact same amount, which is somewhat of a false assumption, but that's what we have to make for this problem. So the variable costs are $4.70 per item times the number of items being produced is also 5,000 plus 10x. So from here, you can put revenue and cost together to write a profit function, which you can then maximize.